Welcome to 10 Minute Climate, the podcast brought to you by Beaverbrook Energy. Join Max.
Hi, I'm Max.
And Tony.
Hi, I'm Tony.
Who between them have got over 70 years of experience in the energy industry, and they're here to share it with you. Each episode, they'll cut through myths, answer the questions you've always wanted to ask, and break down the latest news about the energy transition. It's everything you need to know, delivered in just 10 minutes. So let's get started.
The thing, I've been fascinated about this for a long time. Journey to the centre of the Earth wasn't going to work because it's 6,000 degrees down there.
Well, it's a long way as well.
Yeah.
Arnie Sacknewson was not going to have walked like 7,000 miles in the time it takes for Hollywood to make a movie.
Yeah, it could have been a very long book as well.
Yeah.
But, okay, but there's so much heat down there. There's so much heat. There's so much energy beneath our feet. And we
Pops up occasionally.
It does pop up occasionally, but we've got to be able to use it more. I mean, we are using it. It's geothermal power is what it's called.
Yep.
It's heat down below us. And as we've talked about before, to make electricity, what you really need is heat. You burn stuff or you use nuclear. You heat water, you spin a turbine, right? So we've got to be able to get the heat from beneath our feet and use that.
You can, but it's one of these strategic dilemma problems that the greater the source of heat close to the surface, the less stable it is. Because you've obviously got molten rock coming up in a completely unstable environment, or you've got hot rocks. Iceland, for instance, has got a lot of hot rocks. But in the recent past, Iceland has started to become less stable. It's going through a volcanic cycle where...
When you say less stable, you mean the heat's going up and down, it's fluctuating?
Well, the thing is, it's coming up and it's destroying the pipes and the power stations, because although the pipes and the power stations are fairly robust, a few thousand degrees of molten rock flowing over them tends to cause severe amounts of not working anymore.
But is it always correlated with volcanoes? It's not really.
The thing is, you've either got to drill a hole into the core of the Earth, which is about 6,000 or 7,000 miles away, which is a long pipe to remain stable with plates of the Earth moving around all over the place, or you do it in a place where the heat from the core of the Earth is closer to the surface, which is the tectonic plates around the planet where they come together. You tend to have fractures which allow some of the heat to come up to the surface, which is why you've got the Ring of Fire in the Pacific and things like that.
So we've got
unstable.
Yeah, California.
Yes. And San Andreas Fault.
Yeah, unstable. I mean, Iceland's interesting. They have they're powered pretty much completely from geothermal.
Yes,
I think a very cheap power. It's been there a long time.
Yes,
it's completely carbon free.
Yes,
their prices are on the floor. They use it for heating as well, but they get that you need the hotter water for electricity, which they have. The UK, we don't have a lot. There are a couple down in Cornwall.
Yes, there are, but the reason the UK hasn't got a lot is not because the heat isn't down there, but it hasn't come up. The places where there is lots of geothermal power is where the heat is penetrating the crust and coming up to the surface. Iceland sits at the top of the fault that runs down the middle of the Atlantic, which I don't know if you've seen all the nice, interesting documentaries on the telly. There's lots of bubbly things and strange shrimps and stuff that live on all these little heat cones at the bottom. And they've got a place where the cap of rock doesn't break up that much, but the heat is quite close to the surface. So the whole of Iceland is basically a big hot rock. And it's hot enough to generate steam. But again, it's the dilemma. The hotter you want it, the less stable the source is going to be.
I think what we're saying is there are various ways of doing it. As you said, in Iceland, you can stick a straw in the ground and it's boiling. Boiling water comes out immediately.
Yep.
But obviously, everything's moving around. You've got a volcano exploding, so it's pretty difficult. You've got the mid-range where there's some stuff happening in Cornwall. You can go down 5 kilometres or so. It's expensive.
That's a different type of rock, though.
Right.
The definition geologists will give you of hot rocks is not rocks that are hot, but rocks that generate heat themselves. So they're fundamentally radioactive. Low-level radioactivity.
Okay.
It used to be one of the old adages of the nuclear industry that 2 weeks holiday in Cornwall will give you a bigger radiation dose than working in a nuclear power station for 20 years. Which is quite funny, but true. And what happens is that where you've got rocks, granites and such similar, which have got radioactive decay built into the rock itself, if you get site cracking systems in so the water table can seep into these rocks. That water gets warmed up. You can tap into that, right, which is slightly different from
And you can
volcanic
pump
heat.
water down as well.
You can, yeah, but obviously the thing is that, when you start looking at the comparative cost of doing these things, first of all, even in Cornwall, you've got to go down 7, 8, 9 kilometres, which is a long hole to remain stable. You then probably got to pump water down the hole to get heated to come back up again. So you've got to use energy to get the energy. And then you start looking at the maths and say, is it worth pumping, thousands of tons of water an hour down a hole to get kilowatts out, where if I use the land that I'm drilling the hole on and put solar panels on it, I'll get more
Because
kilowatt hours out.
I think Cornwall has been about 35 million to generate kind of a couple of meg of electricity, which doesn't make sense. I mean,
no commercial organisation will do it unless it's like the Iceland or Chile or somewhere like that.
Or the Great Rift Valley in Kenya does a lot.
Yeah.
Again, it's near the surface. There is new technology coming out of principally America, which is built on the tech invented for shale, which is basically fracking. So you're going down to, I don't know if it's radioactive or just hotter areas, but you're going shallower. And then you're fracturing the rock using the same fracking technology. You're putting fracking fluid in, which is essentially water. You're heating it up and pushing it out again. And there are a few wells drilled, and they think they can scale that significantly. And you don't go down as deep.
Yeah, so then you can get black water and gas out of your plumbing.
Well,
it's the problem is if you start messing with the geology underneath somewhere, you should expect changes. And all of our infrastructure is built on the basis that the ground that it's built on is not going to change very much. This is the Iceland problem. Are you going to spend millions, potentially billions, on a new power station in Iceland only for the geology to move around slightly and wipe it all out in an afternoon?
I think that's the problem with geothermal, because if you think about it, it's drilling, right? We drill stuff all the time for oil and gas. The thing is, oil and gas well, you get a ton of money out of it, right? You hit it.
Only when you win.
Yeah.
Lots of holes are drilled, or used to be, not so much now because geological analysis, but you used to drill a lot of holes before you won a prize.
But even if you do that, the prize is very, very, very big.
Yes.
You've got oil coming out for years. With geothermal, same drilling, you're getting hot water. It's just not worth as much.
Yeah. Because the hot water's cheap. We throw billions of tons of hot water away every year, everywhere.
That's a heating episode. Let's go on to that another time.
Yeah.
But yeah, I mean, I think geothermal is really interesting, but the place, you just can't do it in that many places where the heat's close to the surface, and drilling down further is too expensive. So I think it's a little bit like wind. You can do it in certain places, and it's worth doing in certain places.
Yeah.
But it's not going to solve the energy transition. But we'll have some.
Because of the way the economics is working now, everything is becoming pegged against what do solar and batteries cost.
Yeah.
And that's going to be the deciding cut-off line for every technology going forward.
I agree completely. And more and more as every day goes past, I think it's solar and batteries for 80%, and you've got a bit of wind, a bit of geothermal, some nuclear, a little bit of fossil for whatever reason, and we're done.
Thanks so much for tuning in to today's episode. If you enjoyed the conversation, don't forget to like, subscribe, and leave us a review. It really helps us grow and continue bringing you valuable content. If you're curious to learn more about Beaverbrook Energy and how we're navigating the future of energy, feel free to reach out to us directly. And for those looking for quick, actionable insights on the energy transition, be sure to subscribe to our 10-second climate newsletter, delivered every weekend with essential intelligence to help business leaders stay ahead of the curve. We appreciate you listening, and we look forward to having you join us again next time. Stay informed, stay engaged, and take care.